So today we're going to delve into a new addition to our tools when it comes to dealing with quadratic functions, and that's something called the quadratic formula. The big thing about the quadratic formula is that it becomes really useful whenever we have a certain kind of problem, and let's look at that kind of problem. So let's take this example, x squared plus 6x plus 2. Let's pretend that our goal is to find the zeros or x-intercepts for this problem. So this is what we're trying to find. Now, the first thing a lot of people jump to is that there are two ways to do this. You could look at graphing it, or you could just factor it. Now, a lot of people would jump to factoring it because it's a lot faster than graphing. So let's look at that first. So as we go ahead to factor it, we decide that A, B, and C is 1, 6, and 2. A times C gives us a 2 on top and a 6 on the bottom from B. Now, as we look at this, we know that the factors of 2 are only 1 and 2. Well, that doesn't multiply together to make anything but 2, and when you add them, it only gives you 3. So our two factors don't work out because we can't use 1 and 2 to make 6 on the bottom. Since we can't factor it, maybe we can just jump straight to the graph. Now, if we go ahead and graph it, we're going to get a t-chart, and when we fill in that t-chart, we're going to get a series of values like this. If we go ahead, go over and graph them, create a grid like this. And if we take those points and connect them, you'll notice that our graph, while it is a nice parabola, it doesn't create perfect representations of the zeros. That is, we don't know exactly where they cross the x-axis. So as we move on, we're going to have to find a way to figure out a way how to find exactly where those x-intercepts are without just estimating. So let's look at the quadratic formula. So the quadratic formula is a very special formula, and it goes like this. X equals, our zeros actually, is equal to the negative value of b plus or minus the square root of b squared minus 4ac divided by 2a. Memorize that. The big thing here to remember is that x on the left represents all of our zeros or x-intercepts or solutions. Remember, all three of those things are the same value in general. As we look at it, that x is the answer. It's what our zeros are. That's what we're looking for. If you look at the whole equation, you should notice a couple of things. First off, it still uses A, B, and C, and those are still the same values. They still come from the same places. That is, when we have one of our quadratic functions in standard form, that ax squared plus bx plus c format, A, B, and C still come from the same place. So you know where to get those. Secondly, you might notice that part of the quadratic formula is familiar. In fact, if you look at it, this, negative b divided by 2a. You should hopefully remember that you remember that negative b divided by 2a is the formula that let us find our axis of symmetry, the center of our parabola when we're graphing. The only thing that's really new to us is this section right here, plus or minus the square root of b squared minus 4ac. So let's take a look at what exactly that does. So here's our quadratic formula again. Let's look at just the area underneath that square root symbol, that b squared minus 4ac. Now, this is a very special piece of the quadratic formula, and it's called the discriminant. Now, the discriminant, this b squared minus 4ac, is a special piece. It tells us something interesting about our quadratic function. B squared minus 4a squared, if that value is in fact greater than 0, that is, it's bigger than 0, it's a positive number, we know that our quadratic function has two roots, or two real roots. In other words, when you were to graph it, your little plot will cross the x-axis twice like it does in this example. Now, on the other hand, if b squared minus 4ac is equal to 0, that is, it is actually comes out to 0 perfectly, that means that you only have one root. In other words, when you go ahead and graph it, you're going to find that the parabola only touches the x-axis one time. And finally, if b squared minus 4ac is less than 0, that is, it's a negative number, that means that there are no roots, or no real roots in this case. And that's all that really matters in Algebra 1. So when you graph it, you'll get a parabola that does not touch the x-axis at all. So while the discriminant tells us how many roots it has, the entire quadratic formula is going to tell us exactly what those roots are. So let's use it to find the roots of that original example. So here's our original problem, x squared plus 6x plus 2. Let's find a, b, and c real quick. So that is once again the 1, 6, and 2. Now let's take a look at our formula again. Negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. Let's just fill in the values for a, b, and c. So x equals the negative of 6 plus or minus the square root of 6 squared minus 4 times 1 times 2, all of that divided by 2 times 1. And now let's just simplify. You get x equals negative 6 plus or minus the square root of 36 minus 8 divided by 2. Keep going, and we get negative 6 plus or minus the square root of 28 divided by 2. Now, from here, we really need to decide, what does it mean to say plus or minus? Okay, what does that mean, that weird symbol that has both addition and subtraction? We're going to split the problem into two different problems. The first one will be negative 6 plus the square root of 28 divided by 2. And the second problem will be negative 6 minus the square root of 28 divided by 2. That is, we're both adding and subtracting. We're doing two separate problems. And they're both x equals. Our roots all exist at that point. X equals negative 6 plus the square root of 28 divided by 2. And the other root exists at a negative 6 minus the square root of 28 divided by 2. Now, right now, that's going to be our answer, that x equals negative 6 plus or minus the square root of some number divided by 2 in this case. Now, in the future, we're going to look at different ways to simplify these square roots. But for right now, we're going to leave it right now, and that'll be acceptable. Let's do another example that works out a little more cleanly. Here's our new example, x squared plus 6x plus 5. Once again, let's start by identifying a, b, and c with our quadratic formula. So we've got negative b plus or minus b squared minus 4ac over 2a. A, b, and c identify our 1, 6, and 5. So take our values, plug it into our formula. The negative of 6 plus or minus the square root of 6 squared minus 4 times 1 times 5. And once again, that entire thing is going to be divided by 2 times a, which in this case is 2 times 1. Simplify some more. Negative 6 plus or minus the square root of 36 minus 20 divided by 2. Tried to jump ahead there. So it becomes negative 6 plus or minus square root of 16 divided by 2. Now, here's where this one becomes a lot cleaner or simpler than our last example. What's the square root of 16? Hopefully you remember that the square root of 16 is 4. So we can simplify that square root to negative 6 plus or minus 4 divided by 2. And from here, we'll split it into our two separate problems, our positive and our negative, our addition and our subtraction. Negative 6 plus 4 divided by 2, and negative 6 minus 4 divided by 2. As we work these out, negative 6 plus 4 is equals negative 2. divided by 2. So that becomes x equals negative 1. Our second problem, negative 6 minus 4 becomes negative 10, and negative 10 divided by 2 will give us negative 5. So our second root is x equals negative 5. And those here are our new values. Those are our roots, or x-intercepts, or the zeros for our original problem. Because we were able to simplify that square root of 16 way back in the problem, our answer is a nice whole number. We're going to learn more about simplifying those square roots later on, so don't worry about it yet. So, quadratic formula, that's it. That's the whole thing. X equals negative b plus or minus square root of b squared minus 4ac over 2a. Memorize that. Just remember that it's a way to tell you what your roots are. If you have an unknown x-intercepts, you can't factor it. It'll let you find these exact perfect points for x equals whatever. Wherever that graph crosses the x-axis, this formula is going to get it to you every time. All you have to really remember is that a, b, and c still come from our standard form ax squared plus bx plus c. The a, b, and c are still the same values we're using, so you're not having to find anything new to start this formula. Memorize this. I can't say that hard enough. Memorize it. Plug in your numbers and solve. And we're going to practice that.